Happy Friday, ambitious readers. Welcome back to another edition of Reading Ambitiously, where every single week we're bringing you the most powerful ideas that are shaping our world from all the conversations we're having with the ambitious community. This past week, we've had many conversations about the idea that I'm writing about you today, and I'm really excited to jump into this week's big idea, which is called Harness Engineering and the Future of Software Development. Now, the history of software development is in part the history of abstraction and automation. And over time, engineering teams, what they tend to do is automate more of the mechanics of their job and reallocate their effort to where the human only skills matter the most. Think about the best engineers you know. They are always automating away the parts of the job that they don't enjoy. Now, there was the era of the mainframe where the work sat closer to the machine. In fact, I've interviewed some engineers that told me the most important work they ever did was actually at the transistor level in this particular era. Now, after that came waterfall, which really formalized the sort of sequencing and handoffs and the professional way with which we develop software. And then, of course, agile, which really tightened and shortened the release cycle. And today, many teams operate in a world of continuous delivery and increasingly so, continuous deployment, where the software ships constantly and iteration happens in real time. Now, every time we've been through one of these shifts, it has changed software engineering. More importantly, it changed the craft and where the best in that craft place their focus. What did not happen was we did not stop engineering, but we did stop spending time on the parts that had been automated away, and the locus of value kept moving. This is what makes the rise of agentic coding feel a lot less like a break from history and more like what is a turn in a familiar story. Now, the first phase of this AI cycle was all about prompt engineering. And what we learned is that if you ask the model better questions, you will get better answers. Prompting quickly became one of the most important skills for getting useful results from AI. And all of the major labs released prompting guides. And there are now websites that help you write prompts. In fact, my favorite thing to do is to ask the LLM to help me write a prompt. But as our ambitions expanded, we moved from one-off outputs to real systems, and it became clear that well-written prompts could yield weak results if the model lacked the right information at the right time. Enter context engineering. Now, in addition to clever instructions, what we have learned is that you also need to protect the context window. Think of context as the model's memory at runtime. What should the model see? When should it see it? Which is something that labs are now calling progressive disclosure. And how do we avoid wasting this precious resource? Well, a great deal of innovation in the last year has gone into addressing context rot, which is essentially wasting the context window. And this is something we wrote about in January, and I'll put a link to that reading ambitiously in today's written edition. And what we talked about were tools and plugins and model context protocols and skill libraries and orchestration loops like Ralph Wiggum and RAG. You know, you've heard all these terms. In one way or another, the majority of these innovations are attempts to improve the quality of how we use the context window. And this has been an important deepening of the craft. And prompting certainly did not go away. It just got wrapped up into this growing set of skills and disciplines. We learned that asking well still matters, but you've got to supply the right context in the right sequence into this finite window to get really good results. Well, now the discipline is expanding again because the unit of work is shifting from answering a question to actually completing tasks. The burden has moved from the prompt itself to the system that we build around the LLM. And this is important because now agents are beginning to take on long-running work across multiple steps where they have to use multiple tools and multiple context windows. And so we need what we're starting to call a harness. Enter harness engineering. The tooling, the practices, the testing strategies, the guardrails, the feedback loops that keep the system reliable over time. Once agents are doing meaningful work across all this stuff, the quality of the outcome depends less on a single prompt and more on the system that is engineered around the model. The harness keeps it on track while the work unfolds. And I think that prompt, context, and harness engineering are best understood as cumulative ideas. In my opinion, they really build on one another. And together, what I believe they are doing is starting to define how software gets built going forward. And this matters because when you build software in this way, you can dramatically increase the velocity of your team, but only if you are willing to redefine the job around these new disciplines. And that is something that OpenAI has been working on. Over a 5-month period, they built and shipped a product with zero manual written code. And the repository reportedly reached over 1 million lines. The application logic, the testing, the configuration, the documentation, the tooling, it was all generated by AI. And OpenAI has suggested that it was built in roughly 1/10 the time it would have taken to build by hand. And the engineer's role in this project appears to have been different. When something failed, the answer was not to go look line by line at the code in the code base itself. It was to look at the system. It was to ask what capabilities are missing, what artifacts are unclear, what test was absent, what feedback loop was too weak, and what part of the environment needed to become more legible to the agent. These tasks are beginning to look like the work of a harness engineer. And that is the deeper shift in that engineering judgment is moving from these isolated acts of code writing into the design of the systems that can generate, test, and improve code over time so that the output is high quality, reliable, and at scale. And I'm not sure we've got a name for this phenomenon yet. I think harness engineering is one candidate, but it is certainly the AI word du jour right now. I've heard other terms, regenerative software. I've also heard the phrase AI software factory get used. And I think, as one colleague pointed out, that may be an ode to the way that Tesla manufactures cars and the incredible amount of intellectual property that is actually in the Tesla factory itself. The label itself matters less than the shift that is happening underneath all of this. Prompt engineering, context engineering, and now harness engineering are increasingly looking less like isolated disciplines and more like a connected set of skills for the future craft of manufacturing, building, and engineering software. In systems where the intent goes in, the code comes out, the tests push back, the evals refine the path, and the harness gets stronger every single time. And this is why this looks less like an adjunct to software engineering and more like one path along its next evolution. The craft is not being automated away, I don't think. It is being relocated toward the design and supervision of the systems that produce high quality software. And there's a very historical rhyme here because when we went through the industrialization era, we did not simply replace labor with machinery. We reorganized the work around process, how we measured things, and reliability. And something similar appears to be happening in software. But I think more broadly, it is happening in knowledge work. And why wouldn't it? Why wouldn't knowledge work go through a similar industrial revolution like moment, where each layer of abstraction has tended to push more human effort towards the places where our brains matter the most? Maybe that is just my optimistic view, but it is also our lived experience these past couple of months. Prompt engineering taught us to ask better questions. Context engineering taught us to give the model the right information at the right time. And harness engineering is teaching us that the reliability and quality come from the system that we wrap around the model, as well as the feedback loops that improve that system over time And if this framing holds, the leading software companies are unlikely to treat these coding agents merely as point tools. We're not just going to be buying licenses of Claude code. We're going to begin reinventing our entire software development lifecycle around these ideas because this feels less like a break from history and more like the next turn in a very familiar story. I hope you all have a wonderful weekend, ambitious readers. It is my supreme pleasure to be with you every single week. I look forward to being with you again next week for another edition of Reading Ambitiously. Please take care of each other.